So I have this question here that says use the method of contradiction to prove that the root of 7 is an irrational number here. So now the method of contradiction is that we're going to come up with a statement that's going to contradict 7 being an irrational number. So that statement is simply just saying 7 is a rational number, then we prove the contradiction there. So now here we're going to say prove them. Okay, so we state the method first that we're going to use here. So here we prove, or we are going to prove by using the method of contradiction. Okay, so now this method of contradiction involves us into making an assumption where we assume to say that the root of 7 is a rational number. So we say we assume that the root of 7 is a rational number here. Okay, so that is, so after making this assumption here, we equate it to the form of a rational number. So we just say that is the root of 7 is simply equal to a over b, where a and b have no common factor, and b is not equal to 0 here, like this here. So now, first things first, we're going to get the root of 7, we equate it to a over b here. So we have the root of 7 like this being equal to a over b like this here. So then we square both sides. Now, if you square both sides, you're simply going to have a 7 this side being equal to a squared over b squared like this here. So now, here, if you try to make a squared here the subject, you'll notice that we're going to have this over 1 cross multiplication here. We're going to have a squared is simply equal to 7b squared like this. Let's name this one as equation number 1 here. So now, from this here, you'll be able to notice that a squared is divisible by 7. So if a squared is divisible by 7, simply means that even a itself is a multiple or is divisible by 7 there. So here, from equation 1, a squared is divisible by 7. So if a squared is divisible by 7, then a has a common multiple 7 there. So or a has a factor 7, or a is a factor of 7 here. So this means that even a has a factor seven here. So now, if a has a factor 7 here, then a is simply equal to a 7 multiplied by any number this side, so that it becomes a factor of, so it has a factor 7 there. So now here, this k here can be any integer here, so I can just say where k now is an integer this side here. Okay, now if k is any integer there, then we can just substitute back into the equation that we have here. Where there's a, we're going to put 7k here. there's a squared, we're going to have 7k squared is equal to 7b squared, like this. So now, if we get rid of the brackets this side, we're going to have 49k squared is equal to 7b squared, like this. So then we divide by 7 both sides. Even this side we divide by 7. You're going to notice that b squared will be equal to 7k squared, like this. So we can name this one to be equation number 2 here. So now you notice that from equation number 2 here, b squared is divisible by 7. Then if b squared is divisible by 7, even b has a factor 7. Has a factor 7. Now, if b has a factor 7 and b squared is divisible by 7 here, then a here is a squared is divisible by 7 and a has a factor of 7. This contradicts the initial statement that we had written back here, where we said a and b should have no common factor here. Okay, so we said where a and b have no common factor there. So this becomes a contradiction that we have there. So if that's a contradiction there, then you can just say this is a contradiction. Since A and B have a common factor, seven. Now, if this is a contradiction, then we can just say, and therefore, the root of 7 is an irrational number. Like this. Okay. So there we have the proof there. So we can just go through it one more time. So we prove by method of contradiction. So method of contradiction, we assume that the root of 7 is a rational number. So if it is a rational number, then we equate it to the form of a rational number, which is a over b, where a and b have no common factors. So a and b should not have a common factor there. So step number 2, we equate the root of 7 to a over b. Then when we square both sides, the square root there disappears. Then we have this expression here. So this just simply tells us that a squared is divisible by 7, which implies that a has a factor of 7. So if a has a factor 7, we equate a to 7k there. Then we substitute back into equation number 1 there. Okay. So when you do that, you notice to say that even b squared is divisible by 7. So if b squared is divisible by 7, b has a factor 7, which becomes a contradicting statement to what we started with there. So since that's a contradiction, then the root of 7